Python is an object-oriented programming language, and there are various ways to represent data as objects. Simple data can be represented by dictionaries with key-value pairs, and more complex ones can be represented by some special classes, including named tuple, data class, and Pydantic models. In this video, we will introduce these common data types with simple examples. Dictionary is a built-in data type in Python used to store key-value pairs. We can create a dictionary with curly brackets or with the dict function. If you don't add a type annotation for a dictionary, the values would have type any. We can use the TypedDict class to create a custom type for a dictionary and define the data type for each key of the dictionary. TypedDict is normally used for type annotation of dictionaries, but can also be used as a class to construct a dictionary with key-value pairs as shown in this example. Named tuple is a tuple subclass from the collections package and can be used to create tuple-like objects that behave like both tuple and object. To create a named tuple, we need to call the named tuple factory function by specifying the type name and the field names, which is a list of strings. After that, the named tuple can be used like a normal class. Especially, you can access the values both by indexes and by attributes, but not by keys like dictionaries. Otherwise, you will have a type error. Besides, it also has the limitation of a tuple, in that the values cannot be changed. In Python, there is a special decorator called data class in the data classes package, which can mark a regular class as a so-called data class. Data classes are just regular Python classes, with some magical methods like init and reaper created automatically. They are convenient to store and compare data. However, as shown in the last example, data classes just store the data as it is and don't do any data conversion or validation. The limitations of built-in data classes can be solved by Pydantic data classes. Pydantic data class is a drop-in replacement for the built-in data class with data conversion and validation. The usage of it is exactly the same as before. However, if invalid data is passed in, a validation error will be raised now. Our favorite data type is the base model from Pydantic, which has all the benefits of the data class, plus the advantage that it's more flexible and more powerful. We use annotated and fields to add custom validation rules very conveniently as shown in this example, which requires that the age must be greater than 0. Besides, if the data types can be coerced, they will be coerced automatically, otherwise a validation error will be raised, as in the Pydantic data class example. We just scratched the surface of the powerful Pydantic library and will have a more dedicated video for it later. In this video, we introduced some common data structures, including dictionary, named tuple, data class, and Pydantic model. For very simple key-value pair data, dictionary is normally the best choice because there is no need to create a class for it. TypedDict is optional and is normally used to add type annotations for dictionaries. If we need to access some data by both index and attributes, then named tuple is the choice. And if we need to have data conversion and validation, then Pydantic base model is the best choice. Data class is not as commonly used, and most of its features can be covered by Pydantic models. This is it for this video. Thank you for watching. If you enjoyed the video, please subscribe to my channel for more content.